Okay, this is the last part in this signal encoding technique. That means sending analog data in a form of analog signal, which is very simple. Uh, Very simple part here. Here we have analog data like someone speaking, someone voice or audio or some music, and we want to send it as analog signal. So we have two techniques here. The first one is amplitude modulations. Let's see the plot and we will discuss it here. So what we are going to do here is we have the middle plot. The middle plot is our data, that is our analog data, for example human voice as we speak. The top plot is what is called a carrier frequency. Carrier frequency. We want to send the analog data but at a different frequency that the analog data is based up. So voice, so the human voice ranges from 300 Hz to 3 kilohertz or 4 kilohertz. So the frequency of human voice is less than 3 or 4 kilohertz, but we want to transmit in AM radio wirelessly, let's say in 1 megahertz, so to travel a long distance, so that our signal travel a long distance. So we don't transmit our 4 kilohertz as it is, so we transmit using AM radio about 1 megahertz, so effectively shifting the frequency of the analog data to much a higher frequency, so that the signal can travel a long distance, so we can have small antennas to receive the carrier frequency. So the carrier frequency is the one that we want to send our signal. So for example, for AM radio this may be 950 kilohertz carrier frequency. This represents the analog voice music or an amplitude modulation. So we modify the carrier frequency based upon our input data. So we can see the resulting signal we transmit. You can see that there is a variation of amplitude depending on our input data. So this is a carrier frequency 950 kilohertz. So the human voice 4 kilohertz. So we send it with different frequency our data, but for a positive amplitude we have some magnitude amplitude, a higher magnitude amplitude, but for a negative input, a negative voltage amplitude of input data, we have a lower amplitude value. So by this we change the carrier frequency depending upon our input data. So similarly, when we see the frequency modulation, so we have our input data, human voice, and we have a carrier frequency, let's say 102.1 megahertz FM radio. So what they are going to do is the carrier frequency will not be the same. So here we vary the carrier frequency slightly, so it is not exactly 102.1 megahertz. It varies over time as the input data in our example is high. So we have a lower frequency for a higher amplitude of our input data and slightly higher frequency for a low amplitude voltage of our input data. So when we have a high voltage amplitude or our input data, we have a lower frequency. Then for the lower amplitude of our data, we have a higher frequency. So we change the frequency slightly so that we can send our voice using this carrier frequency by varying its frequency depending upon our input data. So phase modulation is quite similar with frequency modulation, but here we change only the phase. So for a high amplitude voltage of our input data, we send with 5 phase. For the lower amplitude voltage of our input data, we send with phase 0. So by this mechanism we can send our analog data in the form of analog signals. Thank you for listening.